Hello guys, welcome to my channel. This is Uday Pandit and you are watching MEP Technical World. In this video we'll learn about how to read the PLC diagram of the LT panel. So this is the programmable logic controller which is used in LT panel for automation purpose. So before I start the session, I would like to request you, if you are not yet subscribe my channel, please subscribe my channel and also hit the bell icon so you'll get notification regarding my upcoming videos. So let's get started. So here, so this is the PLC, programmable logic controller, and if we talk about its specs, so it has a 16 digital input and 3 analog input, and output is 16 digital outputs. So let's discuss about input section of the PLC. So here we have a power supply. So this is to 24 volt DC operated. So this supply is coming from another shift which we have already discussed in previous video. So from there one is negative and one is positive. Okay, so here we have a like sink and source, so we'll discuss it later. So here let's say, so this is the positive supply coming over here. Okay, and this is the terminal for the PLC inputs, and this is negative. So this is actually power supply, input power supply, which this PLC will be operated through this power. Now come to over here. So all input supply is getting 24 volt plus supply over here. So this is, you can say, jumper. Okay, up to there. So positive supply is here. Now this supply is coming from, so this PLC is getting input from where? So one is auto selection. If we want to operate the LT panel in auto mode, then we have a selector switch. That selector switch has to be in auto mode, so that one is here. So this supply is actually auto mode is getting, yeah, here, yeah, this one is actually auto. So this is getting to PLC, feeding to PLC. So this is for auto input signal. That means if this input will activated, means now PLC will have to act as a auto mode as per the programming. So that would be later logic programming. Now another is input is DG incomer 1 ACB on. If breaker is on, that means input will be fed to this PLC. Similarly, for if breaker will be DG incomer 1, breaker will be trip. At that condition, this will be triggered, and here at that condition also PLC will sense, means DG1 incomer is tripped. Okay, to get the status of this breaker bus DG1 incomer 1 ACB. So 1, in case of 1, it will also get a signal, it will also get a input signal, and then in case of trip it will also get digital input signal. Now another is transformer incomer 1 voltage healthy. That means it will sense the input, PLC will sense the input from here. If the transformer voltage supply is healthy, that means all phase are present and under the voltage and over the voltage range, within the range, that means everything is okay, then it is getting input signal from here. So PLC is monitoring through this as well, whether transformer incomer supply is healthy or not. If it is healthy, then getting from here. Now another is transformer incomer 1 ACB. So if this ACB is on, then means it will get input signal over here. Then if it is trip transformer 1 and incomer 1, then similar, it will get input signal from here, and PLC will decide accordingly as per the programming. And here we have a bus coupler 1 ACB on, so that means it will sense and give the command digital input to over here. It means bus coupler 1 ACB is on. Similar for transformer 2, that is incomer 2 for voltage healthy, it will also monitor the transformer 2 voltage. Then transformer 2 indicator status, transformer 2 trip ACB indication, that will also get through this relays. Auxiliary contact of this breaker ACB. Then again we have a DG1 and DG1 on, and DG1 DG incomer 2 and DG incomer 2 on and trip status. Similarly for bus coupler 2 and then bus coupler 3 as well, and bus coupler trip as well. Okay, now bus coupler on only, and this is for DG3 ACB on and trip status. You will get through this contacts. Actually these are the auxiliary contact of the ACB. Now here we have a 3 source. If we have a 3 DG, as per our requirement, we can select the master DG. Okay, so selection of the master DG we can select from here. So PLC will get input according to this selector switch. So if we put the DG1 master switch over here, that means it will decide, it will take input as a master 1 DG1. Then if we select 2, then it will take DG2 as a master, then 3, then means it is a master selection switch. So accordingly it will get a signal, input signal. Now over here these all are digital inputs. Okay, it means 0 or 1 form, means on or off, that means. So this is the digital. Now over here 3 digital analog input as well. So this is actually variable forms. Over here analog input 0 to 20 milliampere from DG1 kilowatt transducer. That means if DG are operating in parallel as a synchronizing and load sharing, at that time what we can do, suppose this is the DG1 is master, and at what condition, at what load we can switch on the DG2 and then switch on the DG3 as well. So this will depends upon the load reading. So this load will suppose total we have a 1000 watts, 1000 kilowatts. That means first DG will suppose run at 250 kilowatts. Okay, as a master. Then if load goes to 500 kilowatt, let's suppose, then another DG will start. So how it is getting actually, because this is the value 1 2 3 4 like that, so it is not a digital form. So that kilowatt actually converted into 0 to 20 milli ampere through the transducer and transmitter, and that actually input signal is going through here, and this PLC will read, and according to that PLC will give the command for DG on and off, start or stop command. Okay, so this is the input side of the PLC. Now come to output side of the PLC. As per the programming, it will decide, okay, as per the input it will decide what can be done for the as per the input condition, where to give the command, switch on or off. Okay, so that will be decided by PLC as per the programming, as per the logic. So here, so this is the power supply again coming from here. So this is the plus, okay, and this is the minus, and over here these are the relay logic controllers. So okay, so these relay are basically for digital outputs. So according to that, according to the program, this output will work as per the PLC. So over here, suppose this is the positive supply and going over here. Okay, now it is coming over here, and this is the relay, which coil is getting through this positive supply through this NO contact of digital output of this inbuilt relay, which is PLC, and negative is directly from here, which is looping like that, okay, till there. If you look over here, so this is for what? DG1 start command. That means in case suppose let's say your incomer transformer incomer goes off, at that condition what it will detect, the transformer, it will detect transformer signal is off through this transformer incomer 1 voltage healthy through this. If it get off, means it will get signal through this input, through this. According to this input it will decide, PLC will decide as per the logic, it will give the command to DG1 starts, means it will activate this relay and DG1 will be started. So these are the outputs. In this way this PLC will work. Similarly, this is for transformer 1 incomer ACB close command. If DG goes, if again transformer will back, that condition this will be close. Similar for transformer incomer ACB open, then bus coupler close, then this is for bus coupler 1 ACB open, then this is transformer incomer 2 ACB close, then again transformer incomer 2 ACB open, DG2 start, bus coupler 2 close, then bus coupler 2 open. So this will done by according to the logic, according to the input of the PLC, and it will give the outputs accordingly. Then DG3 start, then DG1 stop. So DG1 stop, that depends upon the according to that's inputs, analog inputs over here, which we have already discussed according to the load. Okay, so in this way it will give the command for DG to stop. Now here also to bus coupler fail to close. So these all are digital output signal as per the PLC. So in this way we can do the wiring for programming logic controller of the LT panel. Even we can read the drawing of this PLC in this way. So hope we guys understand about what is PLC and how actually it can be done the wiring inside the LT panel. Okay, so thank you for watching this video. Please like, share, comments and subscribe, and also hit the bell icon so you'll get notification regarding my upcoming videos. Thank you very much. See you again in next video.